geostationary satellites or geosynchronous satellites. These are those satellites for which time period of rotation is equal to the time period of rotation of a planet. Now you know that, for example, Earth, if Earth is revolving in an elliptical orbit about Sun, when Sun is at one of the focus, suppose Earth is at this position. So this is called revolution plus the internal motion of the planet, that is its rotation, that is called its rotational motion. So this type of satellite, that is geostationary, another name is geosynchronous satellite. The time period of rotation of this satellite about the planet would be exactly equal to that of planet. So for Earth it would be 24 hours. So this is how we explain these satellites as, these are such satellites which appear to be stationary at a point from a fixed position on Earth. That is why the name geo and stationary, right? Okay, let's find out what could be the necessary condition or the height at which such kind of satellites can be projected. Because in the last class we formulated this formula for height at which any satellite is projected, and we calculated that minimum height was right. Now for this orbital velocity and height, let's calculate it for geostationary satellites. Time period, here put the value time period to be 24 hours and you can convert it into seconds. Then R is what, 6400 kilometers, which will be further converted into meters. Then G, 9.8 meter per second square. What else? 4 pi, you know, and R, radius of Earth, is this. So by putting all these values, the value of H comes out to be 3.6 into 10 raised to power 7 meters, or this is 36,000 kilometers. So for a satellite to be in geostationary orbit about Earth, minimum distance has to be 36,000 kilometers, and as well as the orbital velocity would be, if I put this value of H in this formula, I'll get 3.1 kilometer per second. So this is the minimum orbital velocity at which geostationary satellite would be orbiting the Earth. In this way, and at this height, we can see that it remains stationary at a single position, though it is revolving or it is rotating very fast about the axis of rotation of Earth, but we find it stationary because the time period of rotation is same for the planet as well as satellite.